Hello and welcome again. So you all remember me, and I'm back for another video of interesting facts. This one is a bit of space related, bit of Earth related. It's about the Vredefort dome couple, depending what language you are. It's a crater created by a meteor, and it is also the oldest known or confirmed meteor crater in the world. It's located here in South Africa, actually not too far from where I'm staying. It took me 20 minutes drive to go there. So, but the thing is, the crater is huge. So even if it's close to where I'm staying, it's still a big area. So I'm 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 staying in Potch, which is at the edges of where the compression had happened. If you look in the image I showed you, I'm showing you, you'll see those mountain ridges. They are huge mountains, but they are compressed. So the meteor comes in, hits the ground, and just pushes the um, the Earth's crust into the compress and then form these mountain ridges. So I was there. I knew about it, but this was my first time I was actually there. Was this weekend? Well, Wednesday, not this weekend. um, and we went to this little town called Venterskroon. I've never even heard of it, and it's only 28 kilometers away from my hometown, but they are situated in these mountain regions, and still they are a few um a few kilometers away from the epicenter. So the entire dome is about 300 kilometers in diameter. So it's a huge rock that fell. Eh, when I was there at the place, they said it's estimated the size of the meteor was about the size of Table Mountain. So imagine this mountain-sized piece of rock falling from space onto the ground. It's no wonder it has a 300 kilometer diameter, which also makes it then a fun, interesting thing because you wouldn't think about it, but since the dome is located in northwest, the main epicenter of the dome is located northwest and um, Free State, with the epicenter, the impact point being in the Free State. But since the dome is so big, it actually reached places like Johannesburg. It reaches, and that's another point I want to bring. In physics, you learn that elements can't be formed on Earth. We can maybe have natural hydrogen, but that's only because hydrogen is the most abundant element all over space. But every other element needs to be formed in stars. That includes gold and platinum and all of that. Like I said in the previous video, neutron stars, you need a massive explosion or whatever, such as the merger of the two neutron stars last year, which created loads and loads of gold. So gold isn't naturally a product of the earth, but it's a result of these meteors coming from space and hitting the earth's crust, and thus pushing gold into the ground. And this is the point I'm trying to make. Johannesburg is in this region, which shows that the gold mines in Gauteng and all of that, they can be, not all of them, but some of them may be related to the original impact crater. That's actually cool if you think about it. Now the next thing And this is a bit harder to understand. Or at least you can understand it, but it's difficult to envision because you can envision meteors as a mountain falling on the earth, pushing gold into the ground. That's not hard. The thing that is for me tough to understand is when it happened. Now, it is estimated that this happened about 2.02 billion years ago, so roughly 2 billion years ago. That is ridiculous long ago. Just try to picture it for yourself. So, the oldest human remains, uh, tricky thing to say, is 4 million years, I think, with the discovery of little food also in South Africa. And there's one in Kenya, I think that's 4.5 million. Now, this 8 billion is 8,000 million. So this is long before anyone walked this earth. In science, you even learn that the first life forms only came about 550 million years, but it's a give or take, so it can go higher, can go low. Even this is no match compared to 2 billion years. Like, it's still 4 times longer than the oldest known life on Earth. So, if you think about it, this happened when the Earth was still just a piece of dust, rock, kind of like Mars, just like this ball. It even happened before the continent split. So, as you all know, we have the world map as we know it: North America, South America, Africa in the middle, Europa, Asia, and then Australia here on the side with all of the islands, Arctic Circle top, Antarctica on the bottom. All of this did not look like that. They are all moving very slow, so we'll outlive it. When we die, we'll still have the same world map like we know, but all of them are constantly moving. For instance, right at this moment, a part of South Africa, the Western Cape, is moving towards Brazil, India. Oh no, Brazil, Argentina, that side. And the top half, mainly here from Hockney and them, they are moving to India side. So a few million years from now, there will be two South Africans, a half and half. It will rip it apart and move away. So the continents move. And when you trace them back, their movements, you get what's known as Pangea, the original supercontinent. One continent, all of the life on Earth were on that continent. This happened even before that split. It was still one continent when that happened. Yeah, it it's hard to describe how old this thing is. Now, you may ask, what is the difference between an asteroid and a meteor? And you may ask, what's the difference between space rocks? And they are all technically the same. They are pieces of rock or minerals or whatever that is coming to fall into the atmosphere. Then they burn up, leaving this huge um, light streak across the sky, and it crashes into. There are a few known cases all over the one. Another famous one for South African people is in Namibia. That one is a smaller one than the Vredefort one, and but that rock is still there. You can actually walk, you can touch the meteor, you can well, I don't know if you can touch it anymore. When I was small, I touched it, but World Heritage sites. So I don't know if it's, but it's at Grootfontein. There's one in 2013 that crashed in Russia, if I'm not mistaken. Then there's, for instance, the Sudbury crater that's in Ontario, which is located in Canada, which is close to the size of the Vredefort one, but not entirely. Also, almost the same age. It's about 1.8 billion years. Now you can say that's still 150 million years different, but when considering you're working with stuff older than life on the planet, it is still, it's a small time. Um, then different ones that have been discovered, like the Popogai crater, also Russia, about 100 kilometers radius. Now, you might have seen the movie 4-1, and then the hammer crashes into the ground and it makes this perfect little circle, like center, and then making the. That's not always how it works. Take this one, for instance, with the Vredefort. It crashed on an angle, so it pushed everything. And in some cases, it can be good or bad. Take the one where it pushes. So he is literally pushing pieces of the earth. This creates dust go in the air. It creates a dust cloud right over the globe, blocks out the sun. We as humans need the sun. The plants also need it. Otherwise, the plants die. Everything eating the plants die. So if you're vegan, you're going to die. If you're a carnivore person that eats both meat and that, you're still going to die, but maybe just a bit longer, because when the plants go, there's still animals, but then yeah, they'll also be the end and will die. So one as big as this will end life on Earth. Well, there might be some animals that might survive, but and then other thing, if that thing were to crash straight on heat and not break his fall with an angle, that may be sometimes strong enough to disable the crust of the earth, which is another bad thing. So yeah, but it can happen that it is straight or at an angle. It just depends. But yeah, it these craters are actually very interesting if you think about it. They produce gold, they have world ending applications, they are huge. Yeah, and at this stage, we don't have any defense mechanism against it. So if there comes one, we'll probably try to blow it up with nuclear bombs, but I think that's at the moment the base we have. Like send a rocket with full of nuclear bombs onto the thing as it's coming towards Earth and blow it up, but that might not even be strong enough. You're working sometimes with mountain, but it can be small ones as well. But these ones, they can be about this size to mountain size. It just depends on which one we find, and that's why you see the shooting stars. They are just small ones, and then they burn up before they even hit the ground. So, thanks, Earth's atmosphere.